So just to give you a quick background in terms of crops in Ireland and how we grow them, about between 7 and 10% of our utilisable area is in crops. The rest of it is in grassland, so it's a relatively small part. There's the potential from a soil and a climate perspective to go up to maybe 30% if we wanted to do from that perspective, but it's a competitive area for land. We have the highest average world yields in wheat, okay, and very high in other cereals as well. But we do have high input systems because the climate, which gives us those yield advantages, if you like, also brings with it some challenges in terms of disease control and that. Our production in terms of crop production is very small scale compared to some of the other big cereal or crop producing parts of the world. Just a point of interest here is that prior to the mid-1970s, virtually all of the crops produced in Ireland were on mixed enterprise farms, okay? And we have to understand that we have changed from that. And typically at that time you might have had 10 years grass, followed by maybe something like 3 years crops, back to grass again. But that has changed since the 70s. Today we have enterprise specialisation, and for very good and economic reasons, okay? We can't necessarily turn the clock back on that. It will be very difficult to do it, but it does have consequences. And the reason being that, with the specialisation, which mechanisation has allowed high-yielding varieties in the crop sense, disease control and all of that, we can produce crops a lot more competitively and less expensively than if we were on a mixed farming enterprises. That is the reality to some extent, but it does bring consequences. So we have very labour-efficient competitive systems, and we have generally maintained our yield capacity, but it's important that we can maintain that into the future as well. Okay, so what we have then as a consequence of that specialisation is that the annual crops in Ireland that we produce are in the same fields basically year on year, right? They're not rotating, okay? That puts us on a lower soil carbon plane than if we had been rotating, all right? And there is a risk, while that plane tends to be classified as a plateau, there is a risk that carbon level could decline in the future. So we need to be very mindful of that and to adopt systems that try and prevent that further decline. So there's a desire to reduce carbon loss. And in that, we have to think of many things. We have to think of the tillage system that creates the conditions for crop growth, which I'm going to talk about. But we also have to think of other things like the actual rotations that we use, cover crops, organic manures. There's a lot of different methods there that we need to look at. So that's just kind of setting the scene or the background there to some extent. So why crop establishment studies, right? We are concerned about sustainability, and apologies, Patricia, I have regeneration in brackets as being the same term. I couldn't get it out of the slide here, I was trying to change it here. But anyway, you know what I mean. But there are general sustainability concerns with tillage, and a lot of those are around soils, in retaining organic matter, maintaining good soil structure, fertility and good soil biology, okay? There's concerns about greenhouse gas emissions, right? The other sustainability concerns we'd have would be about disease, weed and pest control. Can we maintain our control of those into the future? And there's certainly challenges out there that we're meeting in some projects, and I know Rob will be familiar with some of this, your next speaker on his farm. And we have financial sustainability, which is the most important. In other words, farmers won't continue unless it's financially sustainable. But when we're thinking of other systems, and crop establishments in particular, so something like direct drill or min-till or any of those systems, we have to be concerned about the suitability for our climate and our farms and our soils, right? Because these systems evolved originally for slightly different reasons in much drier climates, okay? And it may be wrong to consider we can just adopt those without adaptation, all right? So that's really why we need to look at them in our climate and to look at them in a mechanistic way. There's also a desire out there, I think, not among this group, but in some places, to have simplistic solutions. In other words, to say, well, ploughing is bad, direct drill is good, something else is bad, something else is good. It's not that simple. It's very complex, and we need not to be shy of that. We need to tackle it, realising that this is complex. There's many research challenges. Many aspects of this can take decades to show a response. If you're looking at soil carbon, you don't measure response in terms of a year or two. You do it in terms of decades, maybe. And always when you're considering systems, such as conservation agriculture, regenerative agriculture, there's lots of different components in there. That presents a research challenge, because you often don't know, particularly when you're trying to adapt it to an environment, what component of that system is giving the response or not giving the response that you want. So it's a challenge from a research perspective. And conventional trials are limited, but there's no simple alternatives out there, okay? There's some challenges there. So that's just the background. Just to make it clear what we're talking about, conventional tillage, which is what we mainly use in Ireland to establish annual crops, is normally relatively deep, 200, 250 millimetres deep, and it involves inversion, which is done by the plough. But we can do that much shallower, even with these ploughs or with shallow ploughs. So you can still invert and do less intensive tillage if we want to. But anyhow, we'll come back to that in questions maybe later. But this is the standard, okay? Then that's normally followed, say, for cereal production with something like this operation, which is secondary tillage, bit of consolidation, followed by a secondary tillage maybe down to 75 or 100 millimetres deep, and combined with that a sowing of the crop. That's your conventional system. Your min-till system, ideally a min-till, if you're classifying it as min-till, it should be shallow and it is non-inversion, it should be shallow. In reality in Ireland, it varies a lot in both the depth and intensity. I would say anything from 75 mil, maybe up to 100 mil, we should call as true min-till, okay? But many of our growers are working deeper than that, maybe 100 up to 200 mil. If you're doing that year on year, is it that different from ploughing? Well, in terms of the soil, it's probably not. Okay, so there's huge variation within these systems. If you're working a min-till system, you'll have a cultivator drill. It's similar to an ordinary drill, but it'll work in conditions where there's crop residue left from the previous crop. Another system that's used is strip tillage. This is not a direct drill. It actually cultivates and sows in one pass, if you like, but there is a degree of cultivation, but the amount of cultivation is restricted into strips. So it is a reduced cultivation system. I would classify it as a subsection of min-till. It's not a direct drill as such, because there is cultivation involved. And then the true direct drill, or zero-till or no-till, which I would leave in the same category. Others would differ on this, but the aim of these is seed placement with the absolute minimum amount of soil disturbance. Okay, so that's just to give you a broad categorization of the equipment in terms of establishing annual crops. Okay, our research, we've been doing certain work since 2001. Okay, I won't go through the different eras of that, if you like, but we've looked mainly at crop performance. That's been our primary focus. We've also looked at greenhouse gas emissions from these systems. We've looked at soil effects. We've looked at effects on things like earthworms and slugs and aphids as well. So just to mention that. What I'm going to talk about now just is the results of newer work for the last 3 years, carried out mainly by my colleague Jack Jemison, who's completing a PhD. Jack will be here today, except he's writing up some of this work at the moment. I'm busy doing that, trying to submit in September. But what this has done is we have actually gone out on farms and monitored crops on farms with these different systems, and at the same time we have replicated trials adjacent to Oak Park in our site at Knockbeg. So what I'm going to show you is some of the results of the crop performance and some of those over the next couple of slides. Okay, just to show you what we did, we had 7 farms with each of 3 systems, 21 in total. The systems that we looked at were plough, min-till and direct drill. There were broadly, similar numbers across the different soil textures, all within 100 kilometres of Oak Park, basically. And what we did on those farms is we followed the first wheat crop. So these were wheat crops grown in rotation. The first wheat is the one grown after a break crop, like oilseed rape or beans maybe, or something like that. So we followed the first wheat. So that it was a different field each year for each of 3 years. Okay. So what we recorded was crop establishment, crop growth, crop yield and the components of yield. We looked also at soil texture and soil carbon for some modelling work that we'll report on later. And we looked in detail at all the management inputs on the farms. All right. What we also did was we did the similar sort of thing in Knockbeg, okay, where we did a replicated trial, right? So this gives us more solid grounds for actual comparisons, okay? So we plough, min-till and direct drill. We also had shallow plough. I'm not going to show you that. We have a 5-course rotation, but we followed the same point. The first wheat after oilseed rape was used in this. The direct drill, I would have to say, really only started at the beginning of this experiment. Prior to that, those plots were strip-tilled. Okay, so they were in reduced tillage before that and into direct drill for this. But we did the same measurements on those crops. The difference between this trial and the farm one is that the management of the crops was identical on this trial, other than the crop establishment system. So all other inputs in terms of fertiliser, timing, rates, disease control, weed control was identical across the crops. Okay, so just to keep that in mind. So I'm going to show you just a quick look at some of the results. I'm only going to present crop performance, not economics or not environmental, because that work isn't finished, but that will change things a little bit. Okay, not big, we do standard kind of analysis. The focus farms, we're going to show you analysis as well, but we need to treat that with a degree of caution, because we're looking at systems operated by different farmers, and some of them made different choices, and we'll show you how that maybe affects the results. So if we look at, on the focus farms, just crop establishment, how many plants per square metre over the 3 years. Then I use the same colours. The plough is in red, the yellow bar is min-till, and the green is direct drill. And you can see there that there's some variation in crop establishment, but for winter wheat, we're well over 200 plants per square metre in all 3 years, so there's no problem with the establishment there. 2000, the middle year there, the plough had more establishment, but overall, no huge difference there, or no difference that you'd associate too much with the system. But if you look in Knockbeg, right, you can see that in Knockbeg, actually the direct drill had lower establishment. And this is what we would expect to see. Because remember, Knockbeg, everything was done the same seed rate, the same sowing date. But there's no problem with the establishment rate there. Like over 200 plants, even over 150 will give us a full crop. So it's not a criticism of the system, but it is giving us different establishment. Why you don't see it on the focus farms is because their sowing date tended to be different. They tended to sow earlier with the direct drill system, and some of them were using higher seed rates as well, which gave us the highest establishment out. So there's no great surprise in the results there. If we look at growth, right, the growth of the plant, and we measured at 4 different growth stages. On the vertical axis there, you can see consider that as a rate of growth. We measured it by measuring the light interception of the plants. So on the focus farms, all the systems had identical growth up to the flag leaf stage, which is the last point at which we measured growth. Okay, but in Knockbeg, again, we see the same sort of difference that we saw with the establishment, and it's for the same reason. In other words, the direct drill crop was slower to get going, okay, when it was sown at the same sowing date and the same seed rate. But by growth stage 37, it had caught up. And to be perfectly honest, from a yield perspective, once it has done that, there probably isn't an issue. And that's mirrored, this is 2021, that's mirrored in the next 2 years, very similar results, okay? Let's look though at yield, right? So again, looking at the focus farms though, we do see a difference in yield, all right? But we need to be careful here. These are individual, there's 7 individual farmers. There's lots of things in the system that they adopt, other than just that they've decided to direct drill or decided to min-till. So, and this is going to be interesting when I show you the other half, but certainly in this you can see the direct drill growers tended to have lower yield. But look at it in Knockbeg, where the inputs were the same and everything was the same. There's no significant difference. The plough was nearly a little bit better in 2022, but that didn't quite reach significance, okay? But over the 3 years, no significant difference in yield, okay? So what's happened there? Well, what we can speculate, and we've looked at the figures, the direct drillers in the focus farm group are generally spending less on disease control and a little bit less on fertilizer nitrogen, okay? So they're actually taking a decision to do that. Their anticipation is that their yield potential might be a little bit lower, and they're matching, I suppose, their inputs to that. So it does result in a lower yield. Mind you, in Knockbeg, we see if we had kept the inputs up, maybe the yield would have been the same. This yield difference over here, as I said, we haven't the full economic analysis done, but the economics will favour those a little bit. In other words, I can't say that the economics will be the same for all the systems, but certainly if you looked at those bars from an economic perspective, the fact that they've spent less money on disease control and a little bit less on nitrogen will level out those bars a certain amount. But it's interesting to show anyhow. Okay, but, and here's a major but, this year, which is not in the trial, but we have the same trials in Knockbeg, 23 and 24, that season is going to be hugely different. It is going to be very bad for min-till and direct drill, right? We did get the crops in. We couldn't sow until the 17th of October. Sowed in quite good conditions, but very poor conditions subsequent to that. And basically, our min-till is shallow min-till, and that and the direct drill, we have extremely poor establishment, and we will have poor crops. We've had this before in 2009, 2010, so you could say it's 1 year in 10, but we haven't got enough information to say that. There are other years as well when the min-till and direct drill will be a little bit behind ploughing. but most years our yield has been similar. But on bad seasons and bad autumns, the alternative systems are probably struggling. And that's something we need to be really conscious of, how we adapt these systems to suit our climate if these weather conditions are going to be more if we're going to have a greater frequency of conditions like this. Very quickly, just three more slides to finish off, and they're quick ones. The impact on other factors in our climate. As we measure the impact on soil carbon, we haven't huge amounts of work done on this. The impact on the total carbon amounts of the different establishment systems in our climate is quite small. Okay, if we have more tillage, we will burn off more carbon. Okay, but in our wetter climate, it is not as great as it would be in a drier climate. So that difference is smaller. Okay, but you do get stratification. In other words, where the carbon lies will depend on the depth to which you're working, and it's important not to mix up the two of the things, that the location of the carbon rather than the total carbon. In terms of greenhouse gas emissions, if we're reducing carbon loss from the soil, we're reducing CO2 emissions. But in wetter climates, our nitrous oxide emissions are probably higher with minimum tillage or reduced cultivation systems. Okay, and that's been seen in lots of other work as well, in Scotland, in the UK. Generally in wetter climates, because you have more water-filled pore capacity, you get a little bit more denitrification and a little bit more nitrous oxide production. So that counters the benefit from a carbon perspective. So the net impact on greenhouse gas emissions in our climate, not in other climates, but in our climate, is fairly small, the impact of adopting the systems. But anything we can do to retain soil carbon is good. So I'm not diminishing that at all. Soil fauna, slugs, earthworms and other species are increased by reduced tillage, right? Not so good if it's slugs, but certainly it's valuable in terms of earthworms, and that is proven certain for sure. Also, aphids tend to get confused when crops are established with min-till or direct drill, which is a good thing. I see the light shining there, which means my time is up. Okay, so that's good. Work rates and crop establishment costs are hugely benefited by alternative crop establishment systems, and that's why a lot of the bigger growers have adopted the system in Ireland, okay, because it is generally cheaper and faster to establish your crops. The big challenges, though, I would say in our climate, number one is grass weeds, okay. We risk generally losing the battle relying solely on herbicide across all establishment systems, okay? We need to have more integrated and cultural control methods. There's increasing problems with herbicide resistance. Ploughing is a very useful tool for control, okay, and we can talk about that later, but not to have that in the toolbox mightn't be a good way to be. It is useful for certain grass weeds, not all of them, certain ones. The other problem which compounds it is, if we could delay in establishing winter crops or autumn sowing, not to sow early, it will help for weed control, and it will also help for disease and pest control. It is a good method of doing that. But that is a very risky strategy with non-inversion systems as we currently have them. Okay, so there's a huge compounding factor there with those challenges. So we need to be very, very careful. Okay, these came up backwards. I would say, it's not simple. And I'd say we have to be, in all of this, be careful that we don't talk ourselves into being restricted to systems that may not prove ideal in the long term in our climate. What I'm saying is here, this area is not finished. We still need to work on what the best establishment systems, or indeed mix of systems, is. Okay? So we need to develop our work with systems that suit our climate, because it is climate related. We need to focus on aspects that retain soil carbon for sure, and that includes strong cooperation, cover crops and so on. We need to consider reducing the intensity of the existing establishment systems, so that if we do need to invert or plough once in every 3 or 4 years, we can do that quite shallow and still get most of the benefits, right? There may be a case for more adaptive crop establishment. In other words, where we vary the depth and intensity and whether or not we use inversion, depending on the crops we grow, depending on the season we are or where we are in a particular rotation. So I'll leave it at that. Okay.